this is Mary, and I want to introduce Maria, who is one of our excellent inspectors over here on the public sector side. Maria's gone to quite a few wastewater treatment plants over the past year that she's been here at DLS, and all of her inspection reports are quite interesting on what you can really see out there. And there's the standard stuff that you see, and every once in a while there's bizarre and unusual. And so that's sort of fun for me and fun for us to see and help those workplaces get a little bit more organized and safer for their workers. And one of the reasons when Maria interviewed to join us over here at DLS, one of the things that I really liked is that she's actually been inside some of those wastewater digestion tanks. She's been inside the tank, and she was asked to clean down the sides as part of a crew. So I thought that hands-on experience was really going to help her when she joined us over here at DLS and seeing what goes on at the municipalities. So I'm going to turn the presentation over to Maria, and I think we'll have fun.
Yes. Good morning. I'm Maria Colon. Welcome to the Safety at Wastewater Treatment Plants. For those of you that don't know me, I come from Puerto Rico. I did my bachelor degree and my master's degree in Puerto Rico, my master's degree in industrial hygiene in the University of Puerto Rico. After that, when I finished my studies, I went to work for a consulting company, and that's how I became involved in wastewater treatment plants. I was working filling the risk management program reports for EPA, and there was a big strike in the wastewater treatment plants in Puerto Rico, and we were hired as operators for those treatment plants. And that's how I get involved, and I did some operating work in those in those wastewater treatment plants and filtration plants. I have to get into some pits. I have to clean some tanks with pressure water hose, take up sampling of the water, take samples to test for pH, and so on. When I finished that job, I came to Washington, D.C., and I had the opportunity to work as an industrial hygienist for American University. I worked there for about 2 years. I was assisting the risk manager in the university to oversee bloodborne pathogens, human conservation program, and radiation safety programs. Then, after working for American University, I had the opportunity to come to Massachusetts and work for Harvard University as an assistant of industrial hygienist. I worked there doing comprehensive lab inspections of level 2 and level 3 laboratories. The campus has some pH neutralization system, so I was the person to help the manager of the pH neutralization system oversight or work in the pH neutralization system. Then I spent 3 years working as an assistant industrial hygienist. There, after that, I worked for the Department of Labor, OSHA, as a compliance officer for almost 5 years. And now I'm here working as an industrial safety and health inspector for Massachusetts Department of Labor Standards. So today we're going to talk about safety at wastewater treatment plants. Let's move on to the objectives. Let's see what are the objectives for today for the webinar. So today we're going to familiarize on how a wastewater treatment plant functions, recognize the top 6 hazards that are present in a municipal wastewater treatment plant, and identify applicable federal and state regulations. And here we have a picture of South Essex wastewater treatment plants in Salem, Massachusetts. According to the Bureau of Labor Statistics from 1992 through 2010, there has been 61 deaths in sewage treatment plants, also wastewater treatment plants. Since 2014, the Department of Labor Standards has inspected more than 22 wastewater treatment plants across the state. The safety hazards that we are going to be discussing in the webinar are based on those most frequent warnings that we have issued to the wastewater treatment plants in the state. So from number 1 to number 6, the most written warnings that we have issued, ranking the first one is personal protective equipment, permit required confined spaces, control of hazardous energy or lockout as we know it, electrical hazards we have find out, guarding floor and wall openings and holes, and this is the way the regulations was written before January 2017. We know that walking and working surfaces, part of the regulation was reviewed this year. And the last one, machine guarding. Here in the left side, we can see the OSHA regulation for each of these written warnings. As you know, Massachusetts, the Massachusetts Department of Labor is enforcing OSHA, have adopted OSHA regulation and is enforcing the regulations on public employees. Let's see how a wastewater treatment plant works. And not all treatment plants are the same, depending on the classification of the treatment plants. It's the grade of operation that is required. But grossly, we can see here a flow chart of a wastewater treatment plant. The facilities are meant to treat used water that comes from households, from businesses and industry. Once the influent get into the facility, which by pumps, it goes to a bar stream where big objects are removed. After those big objects such as it can be tree branches, after those big objects are removed, the water is pushed into big removals. So more objects are removed there, but smaller objects. Well, you can find there toys, dentures, eyeglasses. And after that, the water is sent to aeration basin where the organic matter is removed through bacterial activities. After that happens, water will go to a classifier where the sludge will settle down in the bottom. The clean water, it's going to the top. And later on, before sending the water into the ocean or reclamation ponds, the water goes through disinfection. It could be UV disinfection. That's where the wastewater treatment plants are moving nowadays, or chlorine disinfection. Most of the facilities that I have visited, they are trying to eliminate completely the chlorine from their wastewater treatment plant. Okay, let's start to talk about the first safety hazard, or the most written citation. When I say written warning, Massachusetts the Massachusetts Department of Labor issue written warnings if, let's say in OSHA, if there is a finding in a workplace, OSHA will issue a citation. So sometimes I will be using either word. It could be a written warning or a citation. So the first one is personal protective equipment, and we all know personal protective equipment is an important aspect of a health and safety program. It's certainly the last line of defense. We always prefer engineering controls or administrative controls as a way to eliminate or isolate a hazard. But due to the variety of hazards that these employees are exposed in wastewater treatment plants, personal protective equipment should be provided. The first thing that an employer should perform, or is the employer responsibility to do an assessment of the workplace in order to provide the right personal protective equipment. And this means that employer needs to take the time to do a walkthrough, a thorough walkthrough, and observe the tasks that employees are performing to anticipate, to recognize and anticipate hazards that these employees can be exposed. The typical PPE that you can find in a wastewater treatment plant are listed here: chemical resistant gloves, disposable chemical resistant gloves, because you can find a great amount of chemicals such as sodium hydroxide, which is a strong caustic corrosive material. You can find sodium hypochlorite, and employees can be exposed, can be handling these chemicals and can be exposed. So disposable chemical protective clothing, and this PPE could be provided to an employee that probably needs to go into a manhole. Hard hat, steel toes, employees that can be exposed to a falling 200 pounds chlorine gas cylinder, safety glasses and goggles. And I have an anecdote. One day I was escorting one of the contractors that used to go to take water sampling in the pH neutralization system when I was working in the campus. And the sampling port was maybe 2-3 feet below ground level. The person needs to open a hatch door and get into the pit to set up the equipment. And I remembered this employee was setting his equipment to take the samples, and the hinge in the hatch door failed, falling on the head of the contractor. He kind of tumbled, and he was very ashamed that happened to him, but he kind of tumbled and gained composure really quick. But he wasn't wearing a hard hat. I was really concerned, really worried. He told me it's nothing, but I know that hatch door, it was heavy and hit him really hard. So that's not the best way to find out what is the type of personal protective equipment that an employee uses. A walkthrough and an anticipation of what type of hazard, what can happen in terms of impact, penetration, degradation, find out what is the physical state of the chemicals that employees can be exposed. Is it gas? Is it liquid? That's the proper way to provide PPE. What we find when we go out there is, yes, the employer has provided PPE to the employees, but when you ask for the assessment, how did you get to provide this type of PPE to the employee? They haven't performed that. Probably it's PPE that other management or previous management has been provided, or maybe another facility it's the PPE that they have provided, but certainly a hazard assessment has not been done. When you provide PPE to an employee, it's really important that the employee be trained in the use of the PPE. They need to know, the employee needs to know when to use it and how to maintain the PPE, where to find something as simple as where to find every place for that PPE. I went to a workplace and the employee needs to use a hard hat, but his hard hat was broken. And because it was broken, he didn't use it that day. And he had an accident. He was hit on his head with a branch, and he needs some stitches. But something as simple as let the employee know we have spare ones. If it's compromised, the equipment, don't use it. That's our important aspect when an employer, or it's part of the responsibility of an employer when PPE is provided. So here is an assessment that one of the sewer department performed. They perform an assessment for headwork, grid cleaning, water sampling, and if you see, actually here, if water sampling, they only require feet protection. But by experience, I know something else can happen, and probably a hard hat, it could be a good idea. But this is a form that the department that we have and that we provide to employers when we go and when we find out that they have no hazard assessment. And this is a really good starting point for them on how to match the task to the PPE required to perform that task. So let's see, due to the processes that happen on these facilities, many places can be considered as confined spaces. So, but let's see, what is the difference between a confined space and a permit-required confined space? By OSHA definition, a confined space is an area where an employee can go, can get in and do work. The entrance or exit of that area is limited. The employee either has to use a ladder to get in, maybe the employee needs to crawl to get into that space. And it's not meant, or it's not designed for continuous occupancy. What makes it a permit required? A permit required confined spaces will have all those three characteristics, but also it will have what they call a dangerous atmosphere. When we talk about a dangerous atmosphere, we talk about it could have oxygen deficiency. And we know in the treatment of water, the organic removal of water, it's done through bacterial activity that sometimes that the byproduct can be gases such as methane, hydrogen sulfide. Those gases can certainly displace the oxygen or limited the percentage of oxygen in the atmosphere. Another characteristic of a permit-required confined space is sometimes this, for example, methane is a gas that can be explosive. Hydrogen sulfide is a toxic gas that actually is the #1 toxic gas that causes death in permit-required confined spaces, and carbon monoxide. These are potential places or potential areas that can consider confined spaces in a wastewater treatment plant. We see here an aeration basin. Digester, this is where the organic activity happens, and the byproduct of that organic activity is methane and hydrogen sulfide. Methane is a gas that it's lighter than air, so it tends to go up but hydrogen sulfide is heavier. And you can, it could be that that in the top of the tank, the percentage of oxygen be inside the ranges more than 19.5 or 20%. But in the bottom, if the employee needs to go, this gas tends to go to the bottom. Manholes are other places, confined spaces that can be required permit, tanks, sampling pits, and pipes. Let's say an employer has the responsibility to evaluate their workplace and determine if they have permits required confined spaces. If they decide, if the employer decides that its employees are to get into a confined spaces, a confined space written program should be developed and implemented. All confined spaces should be identified. An employee should be trained in the hazards posed to, by getting into a permit required confined space. A communication should be developed with the fire department, posting danger signs on those confined spaces. It's important that the facility have a 4-gas meter. For example, the one that I have used the most, it's a multi-rate that works, and it's in up to date to calibration. In the regulation 1910 1.46, there is an appendix for sewer system entries. Why? Because employees in wastewater treatment plants are meant to enter permits required confined spaces frequently, and these confined spaces are really hard to isolate completely. Water is entered into, can be entered to these places. Gases, it's hard to sometimes isolate gases, and this appendix is specifically for sewer entries. And also the atmosphere in a confined space in a wastewater treatment plant can change abruptly. Here is an example of a confined space find in one of the wastewater treatment plants, and the correction that was made after the warning was written. You can see the confined space now is labeled as a danger and as entered by permit only. And actually they took the lever of that hatch door, so it's not as easy to open or getting into that confined space. You see here it's exactly the same confined space. It's another view of the picture, but they took out the lever and they identified this as a confined space. When we talk about confined spaces, we were talking about the isolation of the space, that it's hard to do. Lockout-tagout program, it's a way that you can isolate or deactivate energy that can harm an employee. These wastewater treatment plants, they have a great quantity of equipment that they deal that to do so the treatment of the water happen. A lot of equipment are underground, pipes are below ground, but there are many equipment that employee needs to work or to provide service and maintenance. A lockout-tagout program should be established when an employee is going to provide service or maintenance, and any part of the employee body is going to be inside that equipment. Employees should be trained on how to perform the deactivation of the energy. Sometimes it takes more than one step to deactivate equipment that is going to be serviced. The employer should perform periodic inspection. Inspection should be performed to make sure employees that are servicing the equipment are not taking shortcuts when they are doing the job. A list of equipment should be developed, the equipment that is meant to be serviced. When we talk about service equipment, it's not about minor adjustment that the employee needs to do when the equipment is working, but we mean service or maintenance schedule, preventing maintenance or service that it needs to be done in the equipment. Most of the time, many times you ask an employer if they have a lockout tagout in place, and many times what they do is they will point out a lockout tagout center like this. But specific procedures on how to deactivate the energy are not in place. And the employee needs to know what is the type of energy. It could be mechanical, hydraulic, pneumatic, electrical. The employee needs to know the type of energy to be deactivated and where that energy can be stored in order to perform lockout tagout. And here, these are potential equipment that should be serviced or that will be in need of service of pumps, electrical motors, valves, and mixing system, grid collectors. We see here a sludge collector. We see here a sludge collector. Here we can see a chain and sprocket, which is guarded, which is good. A scum mixer here that at some point will need service. It's important that the employee understand that not because an equipment is not working and needs service, lockout tagout shouldn't be done. Remember, this equipment run sometimes in time setup, or this equipment when you are providing service can be abruptly activated and start working. This is a grid collector here, and these grid collectors run every day in a wastewater treatment plant. The employee that works in this building service these grid collectors every week because the grid collectors tend to clog. You cannot see it, but in the bottom there is a channel where the water runs and tends to clog, and the employees use a ladder to get into the machine and unclog and take rags or objects that sometimes can get stuck in the machine. Lockout tagout procedure was not being done. When the employee was asked, how do you shut off the machine, he said, well, I just push the red button. The circuit break, it was in the same room. The circuit break that provides energy to the machine, it was in the same room, but for any reason he wasn't doing it. When it was asked, or when the manager was told that this machine needed it to be included in a lockout tagout program, the answer was that this building is going through a big renovation. This is a pretty old machine. We don't even know the manufacturer. I don't think we should include it, but I made it clear, as long as the employee is performing service on it, the machine needs to be included, and it doesn't matter if it's going to last 6 months or 1 month. If part of the body of an employee are meant to be here every week in a weekly basis, the employee should perform the lockout tagout or the deactivation of the machine. Electrical hazards. We know that sewage plants, you can find in the environment, you can find gases that can be explosive. You can have flammable chemicals. Electrical hazards like this that we have found open electrical boxes, a spark can come out, a fire can happen. Fires in wastewater treatment plants are fairly common, and these electrical boxes should be completely closed. You see here, there's no lock in this electrical box. There's no lock. This is an opening here that is it's not necessary. This can compromise the equipment, the system, and nothing should be. They should be completely closed because nothing should be getting there. You don't want a rodent getting there. You don't want a spark coming out of there. In some of these rooms, sometimes chemicals can be really shocky and can tend to accumulate in the equipment, in the walls. And it's really important that these electrical boxes should be completely closed and shut. Here in this picture, we can see nothing should be blocking an electrical box just in case service needs to be performed or an equipment should be shut down. A clear of at least 3 feet in front of these boxes should be observed. Let's see what other electrical hazards we can find. We see here missing knockouts. This should be, you can actually see here, you can see a cable here close in this missing knockout. Here you see a missing blank. Everything should be tightly closed and to be accessible to the person that is going to perform or to provide service or do some work on it. Another electrical hazard that it can be found out there is extension cord used as permanent wire. We know sometimes these facilities are lacking of enough electrical outlets, and they decide to use an extension cord like this. I don't know if you can appreciate, but this is an extension cord that is rolled in this guide rail, and it's going, and it's connected to another electrical cord. Extension cords are not meant, can be formed easily, can represent a trip hazard. And do you see how close this extension cord with no DFCI is to the water? We have water here, we have water running from here. Fall hazards. We know fall hazard, you can find fall hazard in these places due to the different levels and the surfaces where employees are doing job or working. Employees a lot of time have to go to big tanks that are lacking of rail guards. They use, employees have to go to walkaways. Some of these areas sometimes are lack of enough light. So floor holes into which an employee can walk accidentally should be closed. And we see here, we see this pit here where the grate was removed to provide service, but it was never put back. We can see a hole like this where pumps are in the lower level and the controls are here in the top level. This is a hole that it's meant to put equipment or take equipment with the overhead cranes here. It has platforms here, and it has a chain here, which is really good. We see also these crates here. I went to investigate an accident in one of these wastewater treatment plants, and the employee fell into a pit, but it was 2-3 feet down. Water was flowing, and what happened was that the snow accumulated and became ice and compromised the position of the crate. When the employee stepped on the crate, the crate tipped and he went down. He was not seriously injured because the drop was maybe 2-3 feet. But certainly there is a lot of fall and trip hazards in wastewater treatment plants due to spaces, different level of work, or of different levels in the buildings. Floor swamp or holes in swamps like this one here, it should be covered. This pipe rise you see here, a rail guard system should be provided, and the inspector nicely gives this example of how to guard this hole in this pipe rise. Let's move on to machine guarding. We mentioned before that sewage plants are full of equipment that needs service. Well, that equipment also, if has moving parts, needs to be guarded. For example, we have here again the grit collector that we talked previously, and this grit collector has here a chain and sprocket. This here represents a pinch point. If an employee, if any part of the employee gets in the machine, the employee can get harmed. A lot of the equipment in wastewater treatment plants work, they are time set up. They are not running constantly. So a shaft can be stopped at some point, but you don't know when what that equipment is going to start doing its job. So it's really important that the equipment or the pinch point be guarded. In this case, if you appreciate, you see here there are holes. So at some point, this grit collector, this chain and sprockets were guarded, but it wasn't anymore. So what the employer did was to cover this whole part with fiberglass, because they also want to see what's happening inside the machine and if the machine was running well. What equipment should be guarded? Sometimes you find in wastewater treatment plants that there is a workshop. You can find a bench grinder, belts and pulley also for feeder pumps, shaft, and grit collector like this that has chain and sprocket and moving parts. This is a shaft here, and you see in the moment of the picture was taken, it wasn't running, but it runs during the day. So this hole, a person can easily, put a hand or accidentally something happen, get injured in this rotating part here. So this is an example. This is an example here on how that part can be guarded with a metal mesh like this. Machine learning also are included in some places. You can find power tools like this. This is a drill press. These tools can walk if the employee is using, and if it's not anchored, can walk on the employee or can. So anchored, this power tool is really important, and you can see here that the power tool was anchored, neatly anchored to the floor. So what other citation or what other written warnings we have been issuing wastewater treatment plants? Trench protective system in trench for trench boxes. Most of the pipes from where the water runs are below underground. Employees have to drill a hole to get into those pipes and fix them or replace them. And we have found that these trenches, when they become more than 5 feet, they need the employer to protect the employee needs a trench boxes, and lack of trench boxes or lack of shoring has been cited. Other frequent written warning has been the lack of flush facility. As we mentioned before, a very common chemical in wastewater treatment plants are sodium hydroxide, which is a strong corrosive. The flush facility should be readily accessible where these chemicals are handled. Other citations that we have issued are the lack of inspections and maintenance of overhead cranes, and also hearing conservation programs, specifically baseline audiogram and noise survey, because most of the time when we go out there, we see that employers are providing at least one type of ear protection. Things to remember. From all the safety hazards found in wastewater treatment plants, 3 major topics are confined spaces, lockout, tagout, and personal protective equipment. If you have any question, you can type it out. If not, you can contact me. You can maybe send me an email. And I hope you have learned something, and thank you for listening.
Thank you, everybody. I like the pictures that Maria put into her presentation.